All right, get ready to dive deep because today we're all about TON blockchain. We're going to break down how it's aiming for crazy transaction speeds, like the kind that could make or break a blockchain. And trust me, TON's approach is wild.
Yeah, it's really something.
We're going deep into their original white paper, and let me tell you, it's dense, but fascinating stuff.
It really makes you think differently about how blockchains can work.
So, like, usually blockchains have trouble with speed, right? Getting those transactions through fast enough.
Right, it's a huge hurdle. Everyone wants to scale up, but
But one blockchain can only handle so much. It's like, imagine a single road trying to handle all the world's traffic.
impossible.
Right, exactly. TON flips the script on that. Instead of one blockchain trying to be everything, they're like, why not have many?
Multiple blockchains, so like a whole network of them. Yep. They call them work chains and shard chains.
Okay, so break those down for me. What's a work chain in this context?
Think of it like specialized departments, right? One work chain might be all about payments, another handles smart contracts, that sort of thing.
Oh, so it's dividing the work a blockchain does, making it more manageable.
Exactly. And then within each work chain, you've got shard chains. These are like the teams within those departments all working simultaneously.
So instead of one giant office trying to do it all,
You've got specialized teams, each handling a specific part of the workload, making things way more efficient.
okay, that's starting to make sense. But then there's this whole infinite sharding paradigm thing, and that just sounds mind-boggling.
It's where things get really interesting. Essentially, TONN wants to treat each account as if it's on its own little blockchain.
Wait, so each user gets their own mini blockchain. How's that even possible?
It's more like a clever way of organizing things. Imagine having infinite space to build whatever you want, because you're not limited by the constraints of a single blockchain.
So it's not literally infinite, but it feels that way because,
These are no longer bound by the same limitations. It's about scalability on a whole new level.
okay, I'm starting to get it, but then how do all these separate shard chains, all these little pieces, communicate with each other?
That's where instant hypercube routing comes in. Basically, it allows messages to zip between shard chains incredibly quickly.
So no traffic jams in this system, huh?
None whatsoever. It's like having dedicated high-speed connections between every single department and team.
That sounds insanely complex, but also incredibly efficient if they can pull it off.
That's the thing about TON. They're swinging for the fences. It's a bold vision.
Okay, so we've got this whole multi-blockchain highway system, right? But what are they actually moving on these highways? How does TON deal with data?
Ah, that's where things get really elegant. See, most blockchains, they use these like traditional data structures, but TON, they went with something called a bag of cells.
Bag of cells. Okay, that sounds different. I'm going to need you to unpack that one for me.
Sure, sure. Imagine you're building with Legos, right? Each brick, that's your cell, it holds a bit of data, not a ton, maybe 128 bytes. But here's the key. Each cell, it can link to other cells, like you're snapping them together.
So instead of like one big file, it's all these tiny pieces all connected.
Exactly. And it's not just like random data, this structure, it makes up everything in TON. Account balances, how smart contracts work, even the blocks themselves, it's all these interlinked cells.
So it's like the whole system's built with these tiny Legos. It's kind of wild when you think about it. But why go through all that trouble? What's the advantage of this whole bag of cells thing?
Efficiency and security, two huge things when you're talking blockchains.
Okay, I can see how breaking things down into smaller chunks could make things more efficient. But what about security? How does that come in?
Because of this cell structure, TON can use something called Merkle proofs. It's a bit technical, but basically.
Hit me with it.
All right, so say you want to check something in a giant database, right? With Merkle proofs, you don't need to download the whole thing. You just check certain parts of this, like tree of cells.
So it's like, I want to know if a recipe uses salt. I don't need to read the entire cookbook. I just look at the ingredients list.
Exactly. That's the beauty of it. Way faster, way less processing power needed to make sure everything checks out.
So more efficient and more secure. That's a pretty compelling combo.
Yeah.
Okay, so we've covered speed, efficiency, security. But this whole system, it's impressive, but who's making sure it's all on the up and up? Who's running the show, so to speak?
Right, so that's where the validators come in. They're kind of like the guardians of the TON blockchain.
Guardians. Okay, I like it. But how do you become a validator? Is there like a tryout?
Well, you need to have some skin in the game. Literally. You have to stake a significant amount of TON's cryptocurrency to even be considered.
So like a security deposit, you're putting your money where your mouth is, showing you believe in TON.
Precisely. And that stake, it's not just for show. It comes with responsibilities. Validators, they're the ones verifying transactions, adding new blocks to the chain, that sort of thing. They're keeping the whole system honest.
Okay, that makes sense. But what's in it for them? Why go through all that just to be a guardian?
Well, they get rewarded for their efforts, they earn transaction fees, and they get newly created TON coins as, like, a bonus.
So it's incentivized. The more you contribute, the more you stand to gain. Makes sense. But what happens if a validator tries to cheat the system?
Remember that stake they put up? That's the key. If they try to do anything shady, they risk losing it all.
Ah, so it's a deterrent. A pretty powerful one at that.
Exactly. It keeps everyone honest.
Okay, so the system's designed to keep things running smoothly, but what about when things go wrong accidentally? Every system has glitches, right? How does TON deal with that?
That's where things get really interesting. TON has this self-healing capability, which is pretty unique. Basically, alongside each shard chain, there's this separate vertical blockchain running.
Hold on, a vertical blockchain. That sounds intense.
It's basically a backup system. It's constantly monitoring for any errors or discrepancies in the main shard chain.
So if something goes wrong on one, the vertical blockchain can just fix it.
Exactly. And because it's running alongside the main chain, these corrections, they can happen super quickly without like disrupting the entire network.
So it's like having a safety net built right into the system. That's pretty amazing when you think about it. We've talked about so much today, from this wild multi-blockchain structure to these tiny cells that hold all the data, to this self-healing system that keeps everything running smoothly. It's a lot to take in, but it's clear that TON is aiming to be much more than just another blockchain. They're building something truly groundbreaking, something that could change the way we think about online transactions, data storage, and so much more. So even if some of this seemed complex, remember this. TON is trying to build a future where speed, security, and efficiency aren't just buzzwords, they're the expectation. And that's something worth being excited about.